Hello everyone, welcome to the next lecture on the error analysis. Today I will explain you how you can find the error analysis of the trapezoidal rule. I will also explain this concept as well as the numerical examples. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of the numerical analysis. In this playlist you can see the theory lecture related to the trapezoidal rule, Simpson 1/3 rule, Simpson 3/8 rule and their respective MATLAB codes explained in this playlist. You can subscribe my YouTube channel so that when I upload in my next video, you will get the notification. Now, remember students, whenever you have the function fx and you want to integrate from a to b, the geometrically meaning is you have to find the area under the curve. For example, you can easily find the integration of the x square from 0 to 2. So that you will get as answer is 8/3. However, there exists many functions f of x, for example e raised power minus x square. Then you are unable to integrate from a to b of the function e raised power x square analytically. You can't integrate the value of the, you can't find the value of the I. That means you are unable to integrate it analytically. So therefore there is a need of the numerical integration. Fine, you can find the solution of this integration, but that is not the appropriate answer, but it is the approximate answer, and that answer you can obtain with the help of numerical integration. So the meaning is the numerical integration is an iterative approach which are used to solve the problem where the analytical methods fail. Now there are several analytical methods, there are several numerical integration methods named as the trapezoidal rule, Simpson 1/3 rule, Simpson 3/8 rule and so on. Fine, and the theory lecture related to them you can see in this playlist. Now what actually the numerical integration will do? The numerical integration is, instead of taking as a area under the curve, they will divide this range, that is a b minus a, into the finite number of the intervals. That means they divide into the x0, x1 and so on. Corresponding to the value of the x0, they will find the value of the f of x0 and we call as y0. Similarly, corresponding to the value of the x1, they find the function value and then we will call as a y1 and so on. Now based on this, we will define how we can join these y0, y1. If you join this line by the straight line, then the method is called as the trapezoidal rule. On the other hand, if you try to join these points through the parabolic curve, like say this is the parabolic curve, this is the parabolic curve, this is the parabolic curve, then we call as the Simpson 1/3 rule. So right now in this lecture, I will describe the concept of the trapezoidal rule. That means I can join these points through the straight lines. Fine, I can join these points y0, y1, y2 by the straight lines, and the method is known as the composite trapezoidal rule. The detailed explanation of this is available in this theory lecture, which is named as composite trapezoidal rule. Now the formula for how you can integrate from a to b of the y of dx, for more detail you can watch this lecture with the help of the 12 examples. And we also describe in this lecture, if you consider n is my 1, what is the n is? Number of the, you can see this is the number of the bifurcations x0, x1, x2 up to the xn. So that means n is my number of the sub intervals. If you consider n is my 1 only, then instead of consider as the composite, this is only called as the trapezoidal rule. And make sure this formula is very important, n into h is my b minus a. Now in this lecture we will describe the error analysis. What is the meaning of the error? It's very simple. If, for example, in case of the trapezoidal rule, we have to join this by the straight lines and our target is to evaluate this function. So how you can evaluate them? Because we are joining this by the straight line, so the straight line, it may be y is equal to mx plus c or any of the other form of the straight line. That means we can define the function phi of x, which is a polynomial. Fine, in case of the trapezoidal rule, the polynomial is of degree 1. So then we can define the appropriate or approximate function phi which is give the appropriate result as compared to this given interval, and the difference of them is known as the error of the approximation. So based on this concept, we will define the error analysis. Now, how you can derive this result? First of all, I hope student you can like and comment on this video to support my efforts for you. Now, how you can find the error estimates? So if I assume that y is a continuous and the differentiable functions, so once we know it's a continuous and differentiable function, then we can apply the Taylor series. How you can apply the Taylor series corresponding to the point of x naught? So how you can write this number is, this is my x naught plus h into f dash of x naught plus h square by 2 factorial into f double dash of x naught and so on. Or instead of consider the h, I can define the function say x, which is corresponding to the point of x naught plus x minus x naught into the first derivative divided by 1 factorial plus x minus x naught square divided by 2 factorial into second derivative at the point x naught and so on. Fine. So you can use either of the approach. I have used this one. Now, what is the remaining thing is, now if corresponding to the first strip, that is the x0 and x1, that is highlighted in this case, then what is the value of the y1? y1 means the function values at the point of x1. So I can substitute x is my x1. So what is the meaning of that? This is y0 plus x1 minus x0 into y0 dash and so on. Fine. Or you can say the error is integration of the x0 to x1 y of dx, and this is the formula for the trapezoidal rule. Now in order to evaluate the error, our target is to find the value of this expression and find the value of h over 2 y0 plus y1. So let's start with the first case. I can substitute the value of the y in this expression and then you can integrate them. Integration with respect to x. So this is y0 from x0 to x1 plus what is the integration of this? X minus x0 square divided by 2 into y0 dash from x0 to x1 plus what is the integration of this? X minus x0 power 3 into 3 of y0 double dash from x0 to x1 and so on. Fine. Now you can substitute the upper and lower limit. The first part is, if you substitute this limit, it is y0 x1 minus x0 plus if you substitute x1, so it is y0 dash, this is x1 minus x0 square divided by 2. If you substitute x0, this is 0. If you substitute y0 double dash, it is my 3 factorial. Fine, I can say this is the 2 factorial. It is my x1 minus x0 cube, and if you substitute 0, it's a 0 and so on. Fine. Now I can simply take the difference of these two values, x1 minus x0 is my h. So what is the value of this integration? This is my h, this is my h, this is my h. I can say hy, h square and so on. Fine. So this is the expression of this quantity, integration of the x0 y of dx. Now I can find this value of, how you can substitute h over 2 y0. What is the y1? y1 means the value of the x is x1. So I can substitute in this equation, I can substitute x is my x1. So the equation is y0 plus x1 minus x0. x1 minus x0 is my h. So this quantity is my h times y0 dash. This is my h square divided by 2 factorial y double 0 dash and so on. Fine. Now you can open this bracket. It is my twice. If you multiply, 2 will be cancelled. It is hy0. It is h square divided by 2 y0 dash. It is a h cube divided by 4 y0 double dash and so on. Fine. Now I can substitute both the values into the equation number 1. So after substituting the value, you will get E1 is, because you can see this part will be cancelled, h cube cancel, the nth term will be cancelled. The only term which is left behind is minus 1 over 12 h, because no, sorry, it is not a cancel, it's a 3 factorial, it is a 4, 3 factorial is a 6, h cube over 6 minus h cube over 4 into y0 double dash and so on. If you take the LCM, it is minus 1 over 12 h cube. Similarly, this is for this term. Similarly, for this quadrant, that is a x1 to x0, instead of the y0 double dash, it is a y1 double dash. Similarly, for the third quadrant and so on. So the total error, you can add them, it will give you the total error. Now, what is that? This is a y0 double dash, y1 double dash and so on. I can take the maximum value of the y double dash. It is my, I can take the maximum of the y double dash is the values of them. So I can substitute this expression. E will be minus 1 over 12 h cube. So since y, what is the meaning of that? Y double 0 is less than of y double dash or less than equal to. Similarly, y1 double dash is less than equal to y double dash. So that means I can take the modulus value. It will be less than equal to y double dash and so on y double dash. Fine. So I can substitute how many times? This is the n times. So h cube into n y double dash of x. Fine. It is a 12. Sorry. It is not a 1, not a 2, it's a 12. Fine. Now we all know nh is my b minus a. So I can quantity, how I can write that? This is nh into h square. So this value I can substitute as b minus a is the required formula of the trapezoidal rule. So summary, what is the summary is? Whenever you have find the error analysis, your error bound is always b minus a, that is upper and lower limit. H is the step size. What is the h is? B minus a over n, and the maximum value of the second derivative. I will explain you this with the help of the 5 to 6 example in this lecture too. Before start with the numerical example, I hope you can already like and subscribe my YouTube channel as well. Now you can see, for the integration of this, obtain the bounds using the trapezoidal rule. First of all, what is the error is? This is my error bound. Now you can see that they are talking about the trapezoidal rule. For the trapezoidal rule, n is my 1. For the composite trapezoidal rule, n is my greater than 1. The same concept I already explained in my this composite trapezoidal rule lecture. Now, so what is the given to you? What is the fx? You can see fx is 1 over 1 plus x. Why? Because you can compare this function from a to b, f into x, fx into dx. So if you compare them, fx is 1 over, what is the a? A is my 0, b is my 1, n is my 1. So can you find the value of the h? nh is b minus a. So what is the value of the h? H is again my 1. Fine. So if I substitute this value, b minus a, fine, h is 1, n is 1. So I can substitute this value, b is my 1, a is my 0, h is my 1 divided by 12, and the maximum value of this f double dash. What is the range is? 0 to 1. So x varies from 0 to 1. How you can find this value? Again, a very simple. Can you find the first derivative of this function? It is minus 1 over 1 plus x square. Can you find the second derivative? The second derivative is 2 over 1 plus x cube. Fine. So therefore, the maximum value of the x, maximum value of the second derivative, absolute value. Make sure it must be the absolute value. It is maximum of, fine. Now how you can find the maximum value? There are the two methods. You can consider this quantity as say my y. Then what is the first, for the maximum, first derivative to be 0, second derivative to be less than 0. But there is no need. I will tell you the simple shortcut way, because the degree of the denominator is greater than the degree of the numerator. Fine. So that means this function is my decreasing function. Fine. Once this function is my decreasing function, so the maximum is occurring at the lower point. So the maximum occurs at lower point. Fine. On the other hand, if your function is increasing function, then the maximum is occurring at the upper bound. Now in this case, since this is the decreasing function, so whenever this case happen, you can say the function is decreasing. Fine. So now you can see it's a decreasing, so maximum is occurring at the lower point. Lower point is my 0. So you can substitute the value at a 0. So answer is my 2. Fine. Now you can substitute this value. B is my 1, A is my 0, H is my again 1, and this number is my 2. So the answer is 1/6 is my correct answer. Fine. Otherwise, as I told you, you can consider the y is my 2 divided by 1 plus x cube. Fine. You can find this derivative. It is -6 over 1 plus x4. And if you find the second derivative, it is my 24 over 1 plus x power 5. Fine. There is no need, but as I told you, this is the decreasing function. And once it's a decreasing function, the maximum occur at the lower point. If it is an increasing function, maximum occur at the highest point. And this is the answer of this trapezoidal error. Look at the second question. Find the value of the n and h so that the required approximation of this are within 10 raised to power minus 4. That means error is given to you 10 raised to power minus 4. And they are talking about the composite trapezoidal rule, so n must be greater than 1. Now if you look about that, what is given to you? Can you find the fx? Fx is my e raised to power 2x sine 3x. What is the a? A is my 0. What is the b? B is my 2. Can you find the value of the h? B minus a over n, that is 2 over n. Fine. And what is the error in case of the trapezoidal rule? So the error in case of the trapezoidal rule is this part. Fine. And this number is less than equal to 10 raised to power minus 4. It is given to you. I can substitute the value of b. B is my 2 over 12. H we have nothing known, into this is a, I can say is a maximum value. Fine. Maximum value of f double dash. What is the limit is 0 to 2, which is less than equal to 10 raised to power minus 4. Now how you can find the second derivative? Can you find the first derivative of this function? This is the first function, derivative of the second functions. So sine, fine, and plus twice e raised to power 2x of sine 3x. This is the first derivative of the function. Can you find the second derivative? So again, very easy. You can apply the product rule here. The first term is e raised to power 2 into 2 is a sine, plus 3 to the 6 e raised to power 2x cos 3x. This is the byproduct of this part. Plus you can apply the byproduct of this. So 6 e raised to power 2x into cos 3x minus 9 e raised to power 2x sine 3x. Fine. I can combine this sine of 3x and sine of 3x. It's a minus 5 and this is my plus 12. So 12 and 5. Now your target is to find the modulus value. What is the modulus of this? I can write this quantity is my modulus. Fine. And we all know what is the modulus of a minus b. I can write this quantity is modulus of a. So this part is 12 e raised to power 2x cos 3x plus 5 is a constant outside, e raised to power 2x sine 3x. Fine. Again, we all know cosine term is always less than of the 1, because cos is always less than equal to 1. I can say this is 12 e raised to power 2x plus 5 e raised to power 2x. So that will be my 17 e raised to power 2x. Fine. Now your target is to find maximum over the domain x varies from this f double dash of x for this component. Fine. And this part will be maximum of 17 e raised to power 2x when x lies from 0 to 2. Now clearly say exponential function, it is always an increasing function. Fine. It is an increasing function in this domain. So once it's an increasing function, so the maximum value is occurring at the upper bound. Upper bound is my 2. So it will be e raised to power 2 into 2, 4. 17 into e raised to power 4. I can substitute this value here. It is 2 into h square into 17 is my part. Fine. Now can you find the value of the h from this case? What is the h? H is less than equal to under root 6 into 10 raised to power minus 4 divided by 17 e raised to power 4. Now you can do this calculation with the help of the calculator. You will get h is approximately 8.046 into 10 raised to power minus 4. Fine. Now another thing is your target is to find the value of h. I can say h is less than equal to 8.046 10 raised to power minus 4. Now what is the nh is? B minus a. B minus a is my 2. Fine. So h is my 2 over n. I can substitute the value of the h here. It's a 2 over n is less than of 8.046 into 10 raised to power minus 4. So what is the n? N is greater than equal to 2 divided by 8.046 into 10 raised to power minus 4. You can solve this calculation and you will get the answer approximately 2487.4. So therefore the value of the h is less than equal to 8.046 10 raised to power minus 4, and n, because n is a number of the integers. So what is the integer part? You can take it as 2488. 8 is the required answer of this result. Don't forget to like and comment on this video. You can subscribe my channel as well. Consider the function. So a is my 0, b is my 2, function is my 1 over 1 plus x square. How large the n we will chosen? So your target is to find the value of the n so that error is not exceeding. This is the error. This error not exceed 5 into 10 raised to power minus 6. Fine. So definitely once we are choosing the value of the n, that means we are talking about the composite trapezoidal rule, because n may be greater than 1. So I can start with this part, and it is given that this number is my 5 into 10 raised to power minus 6. Fine. We know the b. We know the what is the b? B is my 2, a is my 0. So therefore nh is my b minus a. This is 2. So h will be 2 over n, because my target is to find the value of n. Now I can find the value of the f double dash for the given function f. What is the derivative? Derivative is my minus 2x over 1 plus x square. First derivative. Can you find the second derivative? It is my product division rule. So I can say this is x4. Sorry, it's x square. Fine. So what is the division rule is? 1 plus x square into the derivative of the numerator minus the numerator derivative of the denominator. So twice 1 plus x square into 2x. Now if you take the calculation, you can take 1 plus x square common, it will be cancelled out, and the rest of them you calculate, you will get the expression as this part. So therefore you can find the value of the maximum over the domain 0 to 2 f double dash of x, because it's a modulus value. So I can write this part is 6 x square minus 2 divided by this value. Now how you can find the maximum? Again you can consider this component is my say y. You can find the y dash to be 0 and then find the value of x and check whether this number is greater than 0 or less than 0. But that is a very lengthy procedure. Fine. The best way is you can check whether this function is increasing or decreasing. So you can see the degree of the denominator, what is the degree of denominator is 6, degree of the numerator is my 2. So degree of the denominator is greater than degree of denominator. That means this function is my decreasing function. Once this function is my decreasing, so the maximum is occurring at the lower point. So I can substitute x is equal to 0 in this function, because this is a decreasing function. This is my decreasing. So the maximum is occurring at the point 0. So I can substitute 0 minus 2 divided by 1 absolute value. So what is the answer of this is my plus 2. Fine. Now you can substitute all these values in this given expression. B is my 2, A is my 0, H will be here. So that will be H square is less than, it's a 4, 4 into 3 is a 3. So that is my 15 into 10 raised to power minus 6. H will be less than equal to 15 into 10 raised to power minus 6. Now, how you can find the H? Because we know NH is my B minus A. B minus A is my 2. So H will be my 2 over N. I can substitute here. It's a 2 over N is less than equal to 0.003873. Can you find the value of the N? It is greater than equal to 2 divided by 0.003873. After the solving, you will get the answer as 516.4. Because n is my integer number, so I can say n is greater than equal to 517. So the right answer of this problem is n must be 517 at least, so that you can get the error at not exceeding 5 into 10 raised to power minus 6. Look at one more example. The natural logarithm function of the positive part is defined as this. If you look about this part, A is my x, B is my 1, and what is the f of x is 1 over x. We want to calculate the function ln of 0.75. So what is the ln of 0.75? It is minus 0.75 to 1 dt over t. So in this case, A will be my 0.75, B will be my 1, and f of x will be, because it's a negative sign, so it's a minus 1 over x. In this case also it's a negative. We want to calculate the logarithm by using the trapezoidal rule. What should be the maximum step size h? So your target is to choose the value of the h so that the truncation error bound by this. That means the error is bound by 0.5 10 raised to power minus 3. Again, they are talking about the error, so I can start from the error of the trapezoidal rule, and this part is given as 0.5 10 raised to power minus 3. My target is to calculate the f double dash, because my target is to calculate the 0.75, so the range is 0.75 to 1. So let's start with the f. What is the f? F is my minus 1 over x. What is the first derivative? 1 over x square. What is the second derivative is minus 2 over x cube. Fine. Now, so this is my negative, this is my positive, and this is my negative. So therefore, what is the maximum value? From 0.75, upper limit is 1 of the f double dash of x. So this part will be maximum 0.75 less than x is 1. If you take the modulus, this negative value will be my positive, is a 2 over x cube. Now again, clearly say the degree of the denominator is greater than, so this function is my decreasing, and once this function is decreasing, the maximum value is occurring at the lower limit. So the answer is 2 divided by 0.75 cube, and after the calculation you will get the answer as this component. It's a negative, it's a positive, and it's a negative. Fine. So I can substitute this value in here. What is that? B? B is my 1. What is the A? A is my 0.75, and what is the H? H we need to calculate. Fine. So now you can solve this. Can you find the value of the H? So h square is less than or equal to 0.5 10 raised to power minus 3 into 12 divided by 4.74, and this number is my 0.25. Fine, and this square will be my square root. So your answer will be this part. After the calculation, you will get the answer as 0.0712. So that means the maximum step size is my 0.0712 is the right answer of this problem. So always remember, student, whenever you are trying to find the error, start with this error formula, and then whatever they will ask you, you can calculate this. But make sure, student, before watching this, you have to complete the theory lecture of the composite trapezoidal rule, which is available in this lecture. You must watch it with the help of the 12 examples. It's a very simple approach, and you can get an easy explanation through these lectures. I hope you can like and subscribe my channels. We will see the next lecture on the error analysis of the Simpson 1/3 rule and the Simpson 3/8 rule. Till then, you can share this video with your friends, and don't forget to subscribe my YouTube channel. Best of luck, students. Happy learning.